This video will cover the topic, Introduction to Solving a 3x3 System of Linear Equations. We have already learned how to solve a system of two linear equations with two variables. Now this topic will involve three linear equations with three variables. Let's take a look at the example. Solve the following system. Negative x plus 2y equals 8, 3x plus y minus 2z equals 9, and negative 2x equals negative 4. When we look at this system, the first thing we want to do is find the simplest looking equation. Which one seems to be the simplest?
I think the third one does, because it's already set up so that we can easily solve for x.
Yeah, so when we solve for x, we can then substitute that into another equation to solve for another variable. Then we can substitute again to solve for the final variable. Before we worry about anything though, let us first solve for x.
So I divide both sides by negative 2. So x equals 2, right?
Correct. Now where would you say we should substitute that in?
I think we should substitute that into our first equation for x.
Exactly. We can put 2 into the first equation, now written as negative 2 plus 2y equals 8.
Cool. Now I can solve for y. To do that, we should add 2 to both sides, then divide by 2. I think that makes y equal 5, right?
Correct. Now we have to solve for z. Because we already have x and y, we can plug both into the middle equation. We plug in 2 for x and 5 for y, which is now written as 3 times 2, plug in for x, plus 5, plug in for y, minus 2z equals 9.
Okay, so now I can simplify this by taking 3 times 2, which is 6, and adding 5, which is 11. And now our equation is 11 minus 2z equals 9. I can now subtract 11 on both sides and then divide by negative 2 on both sides to get z equals 1, right?
Correct. By using substitution, we were able to find the solutions for x, y, and z, which again are x equals 2, y equals 5, and z equals 1.